So those parent graphs that you just got done working on, obviously I could have just given you the answers. But then you wouldn't have found out, well, how do the x and y relate to each other? Like when it was x squared, we kind of did that one together. Oh, if I put in this x, it gives me to this point, gets me to this point. And same thing with the other ones. So please realize the things that we're going to go through today work for any of the parent graphs. I just kind of picked one of the parent graphs to talk about. All right? So it could be any of them. All right? We're going to stay away from the step function, that the greatest integer one. It's on the bottom left of your answer key there. We're going to stay away from that one for the most part. It's the rest of them, though, that we're going to want to be able to do. So right here, we're basically, what I'm trying to do is get you shortcuts. How could you get a really good sketch of this graph without having to sit there and do an XY table? Okay, that will prove incredibly helpful in here and if you move on to other classes. And so you notice here I said, well, what if we started with y equals x squared? So that's the parent graph for this example. And I'm saying, basically, what if we decided to put a negative outside, out front of that? Well, what would that do to your xy table? You would put in x, you would square it then, right? Because you would do order of operations, but then you would multiply it by that negative out front, right? So do you agree that it would make all your y values that were positive when you did it before for x squared, it would make them all the opposite of what they were before, right? So I think it's in here. I don't know. You agree that's what it would do, the one in red? It would reflect it, because all of these that were positive before are going to flip down and be negative, right? All of these are going to flip down and do that. So if you, if you tap it, it doesn't work for you. All right? So just draw in what would happen to that parent graph. All it does is reflects it over the x-axis. Okay? So a negative out front reflects it over the x-axis. Well, how is this second one different? Obviously, the parent graph is different. See, the parent graph this time I chose one of the other ones, right? And a lot of you did a really good job of that one, by the way, as I came around. That square root of x looks like that. It's kind of like half a parabola that got turned sideways there. The negative is inside the function. Do you see how this is inside the function versus outside or out front? See the difference? What this does is it reflects it over the y-axis. So it takes that parent graph, whatever you had, I think it's there, and reflects it over the y-axis. Okay? So on this one, just out of curiosity, so you can put that answer in, what if there was also a negative out front? It would reflect it over the y-axis and reflect it over the x-axis. Where would that one end up? Which quadrant? Third, right? It reflected it this way, and then it would reflect it again. It would end up down there, right? Okay, just out of curiosity, I just wanted to see what you would come up with. Okay, that was kind of a combination of the two. I will tell you, this one down here doesn't happen a whole lot. All right, I stick more with the ones where the negative is out front. Those are the ones that are more important in the long run anyways. But they can both happen. So again, out front is reflected over the x-axis, and this one is reflected over the y-axis. So any questions about the reflections? Okay. You notice here we're either adding or subtracting some constant to the function. All right. I would consider that kind of being outside of the function. It's not inside here being squared, is it? No, it's out here all by itself. And notice this parent graph again is x squared, right? And so what would this do to your y values? Right? It would take your parallel, it would do what to every single one of your y values? It would make it 2 more than it was before, right? So all this is going to do is move it up 2. Does that make sense from what you just did? You're getting all these y values, right? And now I'm just going to have to add 2 to every single one of them. And so all it does is moves it up 2. I think it's up there. And apparently that's 2. Now what's probably the easiest point to move? It's that one right there, right? See how that 0, 0 is the easiest point to move, and then move it up. You just move everything up 2. So this y value used to be here. Well, now it's up there. It used to be here. Well, now it's way up there. It just everything moves up 2. Why up 2? Because it was a positive 2. Okay. Parent graph changed. It's x to the third. What's the negative 3 going to do? Again, it's outside. Wow, that was interesting. So what's that going to do? Hopefully not that again. Okay, there we go. So that's going to move it, or what's going to happen to your y values? They're going to be 3 less than they were before, right? And so it moves it down to 3. Apparently that's 3 here. So 1, 2, whoa, 3. Again, what point was easiest to move? That 0, 0, right? Just keep moving those easiest points to move. Okay. So the negatives out front or inside reflect it. Adding or subtracting something to the function moves it up or down. And once again, I kind of consider this being outside the function. Do you notice the difference between these here and the ones we previously had? Am I still adding and subtracting something? Yeah, but I'm doing it before I take it to any of these powers. So see, that's outside the function. I consider this being inside the function because it's being cubed. It's being the absolute value taken of it. But it is still just some constant. This is the hardest one for most people. And anytime in mathematics, when you have something inside parentheses and then squared or cubed or anything, it's always going to be the opposite of what you think. Okay? And if it's inside, it moves it left or right. That's what this one does. This is left or right. And you would think with a +2 that it would move it which way? You would think it'd move it to the right, don't you? Right? But it actually moves it to the left. The reason is, look at it this way. What x value do I have to put in there to get it back to 0? -2, which is why you have to move it left 2. All right? That's really why that works out. And so all you do is just move that whole thing and move it over 2. Once again, that 0, 0 is the easiest point to move, and then just kind of sketch that graph in there. You agree. I've been using parent graphs this whole time. I just use a parent graph, move it over. Okay? So on this next one, is that inside the function or outside? This is inside the function, right? So it's right or left, and it's a -3. So it's going to move to the right 3 because, again, what do you have to put in there to get it back to 0? A +3, right? So it moves it right 3. There it is. Right. Now, if you were just going to graph this one, would you have to graph the parent graph first and then move it? Well, no, you just go put that point over 3 and make your V, all right, and you're done. You don't have to graph them both. Unless you want to, that's fine. So any questions so far? We had negatives that did reflections. We added and subtracted stuff that moved it up and down. Here we're kind of adding and subtracting stuff inside, which moves it right or left. Okay. A few more things that can happen. Those are called dilations. Notice they put some c out front here in its multiplication. So they're saying if c is greater than 1. Okay, so 1.5 or 2 or 5 or 10 or 100, who knows? But that would be greater than 1. What it's going to do, well, what would that do to your y values? You had a bunch of y values before when you did this. What's this going to do to them? It's going to double them in this case, right? Or make them bigger. So do you agree if my y value was here, do you agree it's got to be twice as high this next time? Right? Which one's not going to move in this case? Which one's not actually going to double is 0, right? 0, you double it, you're still at 0, right? And so that's why they say it stretches it. And I know for a fact I'll miss that dot, so we'll just do that. Well, that was pretty close, but it was a little high, I think. But you see how everything got stretched up twice as high as it was before? Okay? Did I have to move it right or left at all? No, because there wasn't anything inside that square root. Up and down at all? No. Did I have to reflect it at all? No. All I had to do here was just make it twice as tall. Now here it says, what if that c value out front, so that should probably say c right there. I don't know why it says x. If that c is between 0 and 1, meaning like a half or a third or a tenth, here it's a half, well, what's that going to do to those y values? Again, think of what you did today. It's going to make them half of what they were before, right? So if the y value was, say, here before, now it's only going to be there, right? And this one's also here. This one would be half. Again, this is the only one that's not going to move, right? That's going to stay where it was. All right, we'll test it this time. Well, I hit one of them. That's not bad. All right. So do you see how they're half what the y values were before? Or some people say that one shrinks vertically, or some people say that one got smushed. I can see where they come up with that. It kind of got smushed and bowed out a little bit, right? Or this one kind of got pulled, that first one. Got pulled up, this one got smushed. How come it doesn't use 1 here? How come 1's not included in this deal? Because if you multiply something by 1, you're right where you started, right? How come negatives aren't involved? Why does it stop at 0? We already did negatives. Negatives are up here on reflections. Okay, that's why we looked up. Let's just try a few more, and we'll save some more for tomorrow. Yeah, it's looking like no homework for today, so that's good. So, do you agree? I'm not going to draw the parent graph in there, but do you agree the parent graph is just x to the third here, right? And it looks kind of something like this. I'm just drawing it over here so that you can see what it in general looks like, right? I don't expect you to sit there and get a ton of y values. I want sketches here, all right? So what does this -1 do to that graph? Now, is that, first that question you should say, is it inside or outside? And it's outside the function. And so what would it do to your y values? It would affect those, right? And how would it affect them? By moving them or making them 1 less, right? So it's going to take this whole thing and move it down how much? So right, it used to start at the origin, so just go down there, make your little point, say that's down 1, and then just go ahead and try and make your little curve through there like that. Again, did I go and get a bunch of y values or anything like that? No, I got the one y value that was important, and I sketched it in from there. Okay? So is number 2 going to be the same graph as number 1? No? Why not? Oh, that negative, it's a -1 though, right? But it happens to be inside, right? And so what does that mean? That's going to move it right, how far? 1. So again, you just move that point. Ah, that looks good. And you just put your little... Was I right with the parent graph? Is it still that one? How do you know? Because it's to the third, right? Okay. Is number 3 also the same parent graph? How do you know? Because it's to the third. Uh-oh. There's a lot of stuff going on here. So in other words, more than one thing can happen? Yeah. So let's deal with it one at a time. Didn't we just deal with that right there? What did that just do in the last example? It moved it right 1, right? So this means right 1. And what do we do with that? Up 3. Very good. So up 3. So right 1, up 3. So somewhere in here, right? Right 1, up 3, we'll say. Everybody agree with my point there? Okay. And then you just go ahead, you get a little sketch in there and say it looks something like that. So any questions on that? Well, we might be able to get these notes done today. We'll see what happens. Parent graph is now the V. Well, that +1 is on the inside. So move it left 1. Move it left 1, put in your V. Uh-oh, it's a 2. In fact, we're going to do this one. I'm going to save number 6. I want you to try number 6 for tomorrow on your own. This is, did I move it up or down or anything because of this 2? Right or left? No, that's just going to make the y value twice what it was before, right? So just kind of exaggerate it. Well, maybe not quite that much, but exaggerate it, saying that V would be stretched up this way, be taller, right? And that might be too much of an exaggeration there, but you get the idea. And then try number 6 for tomorrow.